Welcome to Homework Lib.
Over here we have the following circuit in which we're going to have three resistances. Two of them are going to be in parallel and the other one is going to be connected in series. So the first step is going to be to redraw our circuit employing the R12 resistance that we have. So the redrawn circuit is going to look like this with R12, R3. So the calculation for R12 is going to go through the equation for parallel circuits with resistors. So the equivalent resistance is going to be equal to, for R12, it would be 1 over R1 plus 1 over R2. In this case, the values that are provided is going to be 1 over 12 plus 1 over 18. So the value for R12 is going to be equal to 7.2 ohms. Remember, both of these guys are going to be ohms. So R12 is going to be 7.2 ohms over here. Now we're going to use R12 to find the equivalent resistance for the whole circuit. So for this new step, we're going to have only a single resistance, which is going to be the equivalent resistance. And in this case, the equivalent resistance would be equal to R12 plus R3, since this circuit is going to be in series. So this would be 7.2 ohms plus 24 ohms. So the equivalent resistance corresponds to 31.2 ohms. Now for C, find and show the total current as I. Remember that in this case, the total current is going to be equal to the potential difference, the voltage, divided by the equivalent resistance that we're going to have. So for us, the difference of potential is of 12 volts divided by 31.2 ohms, which gives us 0.3846 amperes. 0.3846 amperes. So now we need to work backwards to find the original circuit, and we want to know the intensities of 1, 2, and intensity of 3. So remember that in a series circuit, all intensities are the same, all of the currents are the same. So in this case, what we're going to find is that the value for the currents are going to be equal to the equivalent one that we're going to have, and what is going to change is the voltage drops. So the voltage drop at 1, 2 is going to be equal to the total in current for 1, 2 times the resistance for 1, 2. So this would be equal to 7.2 ohms times 0.3846 amperes, which gives that V12, which is going to give us 2.77 volts directly on this portion. Now for V3, it would be I3 times R3. So the third resistance is of 24 ohms times the current of 3846 amperes, which gives us 9.23. So over here, 9.23 volts. And finally, we're going to separate R1 and R2 and show what are going to be the currents on each of the cases. So in this case, what we need to remember is that in parallel circuits, all potential difference are the same. So now for this case, the difference of potential is going to be that corresponding to V12. So it would be 2.77 volts. And the intensities for this section the currents for 1 is going to be equal to the difference of potential in 1 divided by the resistance of 1. This is going to be 2.77 volts divided by the resistance, which is 12 ohms, which gives us 0.2308. And the current on 2 would be the difference of potential of 2 divided by resistance of 2, 2.77 volts, divided by 18 ohms, which gives us 1.1538. Sorry, 0.1538. And both of these results are going to be in amperes. And remember that whenever we have parallel circuits, in parallel, the sum of the currents is the net current. So current of 1, 2 would be equal to the current of 1 plus the current of 2, which satisfies the result that we already had before. If you notice, the sum of both of these two values is going to give us the result that we already had. And in this case would be 0.2308 and 0.1538 amperes. So if you want, we can round things up to 3 significant digits on all of the cases. And if we round up the currents to 3 significant digits, the results would be the following. It would be, over here, 0.385 amperes. Over here, the result would be the same for both of them, 0.385 amperes for both of them, 0.385. And I1 and I2 up to 3 significant digits would be 0.231, and I2 would be 0.154 amperes. So this is going to depend on the number of significant digits that your professor is asking. Over here, I'm assuming that it is going to be up to 3, just for the results that we're getting. If you require less or more, you can follow the same procedure. So with that, it would be all. Thank you very much, and have a good one.